So now that we've done the expanded and factored forms of the rational functions and we've looked at the domain, we're going to move on to the y-intercept and we're going to find the y-intercept. Now finding the y-intercept in a rational function is the same as any other function. You need to find the x where the x value is 0. Remember the y-axis on a graph. You've got your x-axis and your y-axis. Any points that are on this y-axis here have an x-coordinate of 0. So any y-intercept that's on the y-axis will have an x-coordinate of 0. So what we're going to do is we're going to plug in 0 for x and see what we get for y. Now there's two ways you can do this. You can do it the long way and plug in the zeros, or you can use a trick that we have to find the y-intercept. And the trick that we have, I'm going to go ahead, I've got all of the equations written out here so we can see them, is that when you plug in 0 for x, you're looking at pretty much eliminating all of the x terms because they're all going to become zeros. So what we can do is we look at the last two constants on the numerator and the denominator. In this case, for example, for number 1, I have -4 over +2. Why am I looking at these? Well, it's the same thing as plugging 0 in for the x's, right? So if I plugged in 0 for my x coordinate, what am I going to be left with? The -4 and the +2. So that's why I can just look at the last two constants. Remember, a constant is a numeric value that does not have a variable attached. It is a constant. It is called a constant because it will not be any other value. -4 will always be -4. X is a variable because x could be different values. So for the first y-intercept, for number 1, I have -4 over +2, which is -2. That's my first y-intercept. So let's look at number 2. Number 2, if I were to plug in 0 for x, I would have 0 plus 6 on top, 0 minus 6 on the bottom. Remember I told you your shortcut is to look at the last two constants. So it would be 6 over -6, which is -1. This was -2. So -1. And let's write this correctly. So this would be y equals -2. I'm going to write this as 6 over 6 equals 1. So y equals, 6 over -6, so -1, so that you can see it. And I'll circle the y-intercept. Okay. So now let's look at number 3. Number 3, same thing. Look at the last two. If you want to do it the long way, you can substitute the 0 in for x. But we don't really need to because, again, those are all going to cancel anyway. So I have 5 over -1, which is going to be -5. So my y-intercept for this one is 5 over -1. So y equals -5. Those are your y-intercepts that we're finding. So let's look at number 4. Number 4, again, for y-intercept, that's where x is 0. I can look at the last two constants, 2 over 1. And 2, if you want to do it the long way, you can substitute the 0 in for the x. It's up to you. But you're going to find the same thing. It'll end up with 2 over 1, which is 2. So my y-intercept for number 4 is y equals 2. These are y-intercepts. This is where the graph is going to intersect the y-axis. Now let's look at number 5. We got a particular issue with number 5. There is no constant on the bottom of the fraction. So what you have to do is create a placeholder. So instead of just having nothing there, that's the same as having +0. It's just a placeholder. It doesn't change the value, but since we don't have it, it's +0. Well, if I look at my last two values now, what happens? I get 4 over 0. Can we do that? No, we can't. That's dividing by 0. That means that for number 5, there is none. There is no y-intercept. And you could have seen that coming because in the domain, what is one of the values we cannot input for x? 0. That means that that value does not exist. There is no value for when x is 0. Therefore, there is no y-intercept. If you wanted to do it the long way without the placeholder, you would have 0 plus 4 over 0 squared plus 4 times 0. And you can see 0 squared plus 4 times 0 is just going to turn into 0, and you're going to end up again with 4 over 0. Can't do it. Okay? Now, that's from expanded form. What if we did it in factored form? Well, factored form, you would have to plug it in straight away because we don't have it expanded like we do up here where you can get the last two values. That's our shortcut. Can't do the shortcut in factored form. Factored form, you would just have to plug that 0 in and multiply it out and solve it, which is okay, but again, you would end up with 4 over 0, which doesn't work. So either way is an option. It's up to you. So let's look at number 6. I've got number 6 here, and I've got number 6 in factored form, and I've got number 6 in expanded. Remember, expanded is the one that we want because I'm looking for the last two constants. Remember, this would be the same thing as if I plugged in 0. Sorry about running out of room here. You would get the same thing. Everything would cancel out except for the 1 and the 3. So 1 over negative 3 is negative 1/3. So for number 6, I've got 1 over negative 3, so y equals negative 1/3. That is your y-intercept for number 6. Now, again, I'm not going to do factored form. Factored form is not as convenient. If you wanted to, you could plug in. You'd have 0 plus 1 over 0 plus 1 times 0 minus 3. And you'd have to multiply everything out, and you would end up with 1 on top and negative 3 on the bottom. So it's going to be the same thing. Number 7, again, we've got it in expanded form. So let's look at our last two. So I've got negative 8 over negative 2, and negative over negative is a positive, so it is at 4. So negative 8 over negative 2 gives us a y-intercept of 4. So that's our y-intercept for number 7. All right, let's look at number 8. And again, for number 7, if you wanted to plug in the zeros, you could. You would have 0 plus 4 up top, and 0 minus 2 up top, and you would have 0 minus 2 on the bottom, and 0 plus 1. That would give you negative 8 over negative 2, which is the same answer. Number 8, we have expanded form and factored form. I want to use expanded form. I'm going to use the shortcut. Remember, your y-intercept is where all of your x's are zeros, so you plug in 0 for everything, which just leaves you with your two constants. So negative 6 over negative 2 gives you positive 3, negative over a negative. So for number 8, negative 6 over negative 2, so y is positive 3. So again, these are your y-intercepts. These are where the graph is going to cross the y-axis. This is where x is equal to 0. Okay, let's look at number 9. Again, number 8, factored form, plug in if you want. You can do 0 minus 3 times 0 plus 2 over 0 plus 2 times 0 minus 1. Takes a little bit longer, but you'll end up in the same spot, negative 6 over negative 2. Number 9, let's look at expanded form. So I've got positive 12 over negative 6, which is negative 2. So positive 12 over negative 6, so my y-intercept is negative 2. Do it the long way. You have 0 plus 4 times 0 plus 3 over 0 plus 3 times 0 minus 2. You're going to end up in the same spot with 12 over negative 6. So let's do the last one. Let's do number 10. And I've got 4 over negative 2, which gives me negative 2. So my y-intercept is negative 2. Do it the long way. Plug in. You would have 0 plus 4 on top, 0 plus 2 times 0 minus 1 on the bottom, and you would end up again with 4 over negative 2, which is where you started. So that's how you calculate the y-intercept for a rational function.